Hi everybody, this is Geert-Jan, product manager at NetBeans, sitting in Prague together with
Jaroslav Tulach. Hello, Geert-Jan.
Hi Jarda. So we are actually here to talk about a special project that you've been working on in your free time.
That's true. I call it Bck2Brwsr, and basically it is trying to build on the success of Easel, because NetBeans 7.3 is coming with extremely nice HTML5 editing support, and when talking about HTML5 we need to talk about JavaScript, but I don't want to talk about JavaScript at all.
So this is, from what I understand, because I know about as much as anyone watching this screencast, my understanding of what this is coding Java in the browser.
Yeah, we can achieve that as well, but we can also code Java inside of the NetBeans IDE. Just run it inside of the browser.
Yes, exactly. So you're going to show us how this is done via your Bck2Brwsr solution.
Okay, so I guess let's start with demo.
Okay.
That's a visual thing, and we will at least get up to the speed. So this is NetBeans IDE. I can click on the icon to create new project, and I need to select Maven project type and choose project from archetype. And because my project is called Bck2Brwsr, so let's try to seek for Bck2Brwsr.
So in which repository is this archetype?
In the local repository. Basically, if you want to get this archetype, you need to build the project first. The Maven inserts this project type into your local repository, and then you can start to use it. What I'm working right now is to publish that on java.net repository, but it will take some time.
Okay, looking forward to that.
Okay, so Bck2Brwsr Maven project. Okay, let's do it. Now the name, Bck2Brwsr rocks.
Okay.
Yeah. And we can press finish. And now Maven does all the hard work of setting up the project. From the archetype, it generates project with some skeletal structure.
So the three projects all came from this archetype, or this one project?
This one project.
Okay.
The other one are sources that I will need later.
Okay.
Probably.
Okay.
So this one project, let's look what it contains. It contains Java class, and it also contains HTML page.
Okay.
So, okay, let's run it. Let's run it first. Run project. So when you decide to run this project, it's real Maven project. Maven does the compilation. The Java class is compiled. The only thing which is different is execution. Instead of running the project in classical virtual machine, we are starting a browser. So this is a browser, and it basically shows the capabilities. So here I can type hello Geert-Jan, and you can see that immediately the title is upgraded as I type, and when I press button I can execute some code. So I press say hello, and this is rendered as an image.
So what does this look like in the source of the browser? If you go to the source of this, what can we see?
Let's do it.
All right.
So it basically looks like an HTML page.
Right.
And the thing there, which is something new, is launching a script which is called Bck2Brwsr.js.
And this is in that project that you launched?
This is served by the server.
Okay.
Which is running on background. So basically, during the execution, we also started a Grizzly server on a local port.
Okay.
So here is it. This is the server running on port 62305, and it's serving these pages. Those pages are based on content of the project plus some additional pages, and one of them is the JavaScript, which basically contains my attempt to implement a Java virtual machine. That runs inside of a browser. And the only piece of JavaScript we really need is to load a class. And we load our application class.
And what does that class look like?
Yeah, okay, so we cannot see that in the browser.
No.
Because it's Java, and the class is inside of the project. So this is how the class looks like.
Lots of annotations, of course, because you are famous for annotations.
And actually, the annotations are quite powerful, because one thing that we can really benefit from is basically model an HTML page inside of Java. So this annotation, the page annotation, basically reads content of your HTML page. And it generates a class called index, which is representing what is important inside of your page.
So these are compile time annotations.
Yes.
So when you compile this, you get an index.class file.
Right.
Okay.
And you can basically start to use it immediately. So this is how the page looks like. And it contains some elements which are identified by IDs. Like this one and the title, third one, button. So we now have a chance to work with those elements in a page in a completely type-safe way. So for example, here I have an index instance that is representing my page, and I can use code completion. So
this looks a lot like annotation usage in NetBeans platform applications. Somehow receiving an index or some class, in that case from the file system, and getting properties from there and using that in your code.
I guess this goes even further, because in NetBeans APIs we are not processing HTML page. So here really we are extracting the important elements from inside of the page, like the canvas, those identified with IDs.
So when you get this index.class, what is in that class? I mean, you've converted an XHTML page to a Java class.
Exactly, and it contains fields, and one of the fields is called canvas, and it's really representing this element.
Okay.
And if you want to work with that element, you can just access the field and call methods on the canvas. And you really see that it has a method getContext, which returns graphic context, which would not be true for if you basically try to access another field, like button.
Wow.
Button, of course, doesn't have getContext method.
So this canvas and hello, and what is the other one? Input. So, and we can see those in the XHTML page.
Yes.
If you go back there.
They are coming from the index HTML page. So this is canvas, this is button, this is input, and we can also now we can.
But those are the names of the IDs, right? If you go back to the.
Yes. The names of the variables
so
are extracted
input,
and
hello.
capitalized names from the IDs.
Wow.
Yeah.
That's cool.
And it's type safe,
which
is great success for Java compared to JavaScript, which
and great success for code completion as well, because now you can use code completion to get those IDs that are defined in the HTML page.
And you can call methods on them, get value, set value, things like that. So
it's somehow very weird.
Weird.
Yeah.
That's the new way how to write HTML5 application
using
Java.
Okay, but Google Web Toolkit, you also write in Java in that context, and you somehow get web pages from that. You get JavaScript generated from that. In this case, it's not JavaScript, but it's Java.
In this case, we are really working with Java class files, which has benefits. It's definitely closer virtual machine to the real hotspot virtual machine. It supports reflection. It supports dynamic class loading, if you want. And that's something that is completely missing from GWT because of its approach to compile to JavaScript too early.
Okay.
I'd say.
So let's look at those annotations. So you've looked at the page annotation. There's also a property and an on and a computed property. What is that?
Yeah, okay. So let's start with on annotation. So, of course, when you have an HTML page, you want to associate some behavior to its elements. And for that, we have on annotation. And you can basically annotate any method inside of your controller class with on annotation and select an event which you want to react to. So these are the classical events defined by HTML. And then you want to associate this action with some elements inside of the page. And again, you cannot make a typo. If you choose ID, which is not correct, the annotation processor immediately verifies that there is an error because ID does not exist. We know only about canvas, hello, and input.
Great.
So this prevents typos early in the development phase. And also, you can use code completion. So if I press Control Space,
Perfect.
well, I see the elements which are inside of the page.
Would it be possible to have documentation support in that pop-up? How would that appear there?
And what would be there?
Some description of what that ID is for, or
Well, okay, sure.
Yeah.
Basically, annotation processors are capable of providing completion items, and completion item is defined by two things. First of all, the text that can be completed into the annotation attribute, and also some description.
Sure.
So the description can be more meaningful than in this case. I just didn't know what to write there. This is first time I hear a request like that.
But so what would you have to define in the index page to get that documentation there?
Actually, nothing.
Nothing,
because what we are currently working on is automatic generation of these classes and basically improvements of the annotation processor that will read the HTML5 specification, or that will be derived from HTML5 specification. So very likely you would be able to see a description of what hello is button. So what basically HTML5 button means.
Okay. So this on annotation, so it's, when you compile this application, what happens to the on annotation in the?
So
I mean, how is that linked when you click on that button?
I guess you still remember the part of JavaScript that we have inside of our HTML page.
Yes.
So basically what it does, I can show it here, it loads the application class.
Right.
And by loading the class, we also execute static initializer.
Okay.
So this class does the binding.
Okay.
It basically creates instance of the page model, and it says apply bindings. So at that moment, the application logic is binded to the page, which is inside of the browser.
Okay. So here you have an on annotation. Is there also off, or what other annotations for behavior in the page are there?
The really important annotation is property.
Okay.
Because it allows you to create model view controller type application, which is basically all the modern JavaScript frameworks, like for example Knockout.js,
right,
are leading towards direction where you basically create the application logic as a separate entity, and then the page is just binding to the separate to the entity, to the model itself. So I'm trying to do the same thing inside of Java. And basically, the property annotation is instructing the annotation processor to create a property name inside of the class index.
Okay.
And then we can use it. We will get getter and setter for the right type. So it really simplifies the boilerplate code. You don't need to write getter, setter,
so write another.
Like it's generated.
Write another property.
Right, another property. Okay, property will be property. No, property. Name. Show. Type. Boolean.
Okay.
So
now use code completion.
Let's try to use code completion. We should have the method. We should have the method there. Do we have it? Scanning for suggestions. Okay.
It's show.
Is show and set show is here. So
okay.
basically, this is a simple way how you can enhance the properties of your page.
Wow.
And
so how would you use? So are you using that name property somewhere now?
Yes. We
Okay.
do.
In the hello message.
Well, actually, this is another important property, which is saying computed property. You can basically derive property from existing properties. So what this definition, what this hello message method says is, dear annotation processor, please create me hello message property, which is derived from a value of property name.
Okay.
So whenever the name changes, I will also change a bit. And I'm computing the derived property like this. And of course,
And where is
if I'm
this?
working with the model, I can see also
Okay.
hello get message.
Okay, okay.
I have only getter for derived properties.
Okay. So one thing I see happening is a lot of usage of static. Is that a good thing? I mean, you can have more and more static declarations in these classes, right?
Yes.
Isn't that a downside?
Downside. Actually, it's not a downside. It's we are using static methods, but you can see that we have no static variables.
Mm-hmm.
So these methods, all the context that these methods are working on is derived from the parameters.
Mm-hmm.
So even the method is static, it is really a behavior which is independent from any static state. So that's using static in this style should be completely safe, and
Okay.
even for testability, which we
Yeah.
will talk about later. I guess.
Okay, and the second question I have is, with annotations, on the one hand it's nice, on the other hand, if there are many annotations, as you see in Java EE, in the Java EE world, it becomes difficult to know what to use when and where. So I'm just concerned that there might be many annotations in the end. Or are you focused on providing as small a subset as possible?
Well,
Or
I'm
are there more annotations than this right now?
no,
Yeah.
these are all.
This is all.
And basically, what I'm trying to focus on is to provide really concise developer experience.
Right.
So the property annotation is there to save you from typing one field and two methods.
Right.
You don't want to do that.
Right.
The computed property is also simplifying notification. So we basically have a graph of dependencies between various properties. So we know that as soon as as name changes, like this, also the hello message is changing,
Right.
and this is all this logic is all generated on behind. So it's probably a good trade-off for using these annotations.
So can you talk again a bit more about how these are connected? What is going on behind this
So
to cause this? What is the processing going on here?
So the I mentioned the MVVC design style as used by Knockout.js, and basically this project is reusing Knockout.js. So we are
Literally reusing Knockout
yes.
code from Knockout.js.
Yes,
Okay.
yes. The only thing that I did differently is I provided bindings from the Java to Knockout. So you don't need to use JavaScript.
Mhm.
You can really code it in Java. But this is happening behind the scenes, so
Okay.
you don't need to know. What you need to know is how an HTML page can reference a property from the model. And you do it using data bind attribute of various elements. So for example,
And this is an existing attribute. This is not something that you've created.
this is provided by Knockout.js.
Oh, this is a Knockout.js
So
attribute.
every
Okay.
any user of Knockout.js will find it completely familiar,
Right. Okay.
because this is how Knockout does it. So it just says the value of the input field is associated with name. So
Mhm.
whenever the name changes, we can change the property name, and also whenever the input is changed by the user, the name property should be updated. Also, we are saying, okay, the header is showing hello message text, which is the derived property.
Right.
That's it. So what I can do, for example, I can create a new button. Katjan. Let's call it rename. So now I have a button, and I need to associate it with some behavior. So let's go here, and let's type the handle code. Rename to Katjan. We will work on index. and we will use the on annotation. So on, Evan, again we can do click, ID, string, and
cool.
Katja.
This is why code completion is great.
Yeah, exactly. I don't need to type much. Most of the things are suggested. So here, set name, Katja. Oops. Okay, and now I guess we can run it. So let's try what this will do. So again, regular Java compilation, and then just starting the server and showing the browser.
Okay.
So now the page is initialized, and I can type click rename. And what it does is calling the setter, set name, and the Knockout.js on behind the scene immediately knows that these elements should be immediately changed as well.
Right. So let's quickly go to a couple of the other examples that you have. You have some other things prepared. I think the basics are clear.
Basics are clear, but let me demonstrate the benefits of separating the application logic from the page.
From the view, yeah.
It really helps testing, and the archetype project generates 3 testing classes showing various ways how you can test your application. So first of all, it's a regular unit test, and here is basically demonstrated the benefit of having the index class completely independent from the page. So you can initialize instance of your model, and you can call a setter on it, and then verify that the derived behavior of the setter is correct.
Very nice.
That means the property is computed correctly. And when you run this test, it runs inside of regular Java. It's really completely independent from the browser, which is really
cool.
beneficial. Yeah. So for testing your application logic, this is the kind of test that you want to use.
Very nice. Yeah.
Tests running on the computer is not the fastest one,
cool.
And we should have the test. Open the test results window. That all tests passed. Here is the test that was running.
Great.
Okay, so this is for your application logic. And that's basically all you need to test in case you trust the API to do the binding correctly, which it does most of the time, except when it does not. And if you have a problem with really verifying that things work correctly in a browser, you can write integration test. And this integration test is reusing special annotation called browser test.
Okay, another annotation that comes from you.
But only for testing. This is a testing annotation. And what it basically says is, before launching this test method, please set up a browser in a way that it contains this HTML code inside of itself. And the test then really works inside of the browser, manipulating the DOM file, and it really checks that if you change the value of input element to say Happy Joe, the value inside of the model is also updated. So let me run this test now, test file, and this time it should be slower because this test is starting the browser.
Okay.
So we
should we see the browser as well?
We should see the browser as well. So right now it starts the HTTP server on behind, and now it launches the browser. The browser connects to the server and gets instruction to basically perform our test method while setting up the HTML page. And as you could see below a few seconds ago, the page was really there for a while. Now it's gone because the test executed. And when I look into the test results, I can really see that it executed and it generated an error. So something is wrong with the binding in this case.
Sure.
It works on Linux and Chrome. This is the first time I'm testing on this machine, not with Firefox. Firefox on Linux is good as well. Okay, so this is an example of integration test which you can use. The last thing is, of course, the goal of the Bck2Brwsr project is to emulate Java as closely as possible. Not that we would have all the Java APIs inside of the browser, but those that are there need to behave the same way how they behave on the client.
Okay.
So for that, we have yet another testing annotation, which is called compare. And inside of the method, you can basically compute anything and return a result. It may be integer, string, or other object. And what the system is going to do, it will and I will run the test. It will basically execute this testing method 2 times. First of all, it will execute it inside of hotspot virtual machine, get the result, and then it will run the same method inside of the Bck2Brwsr virtual machine,
Okay.
and it will compare the results.
Okay.
And if they are the same, well, then everything is correctly. And if they are not, you have an easy way how to report back for the Bck2Brwsr project, saying, okay, this is an inconsistency, and here is a test that you can execute to see the inconsistency. Let's look at test results. And basically, we have 3 tests here. First of all, running in Java, then running in JavaScript, and then comparing whether the Java and JavaScript results are the same. In this case, hash code of a string is computed properly. Okay, so that's about testing, and I think it's a strong point in the
Very
story.
nice.
In the
It's
story.
very strong. Yeah.
And I have yet another demo. This is basically my testing example. It's called calculator. So let's run it. Again, does compilation, launches the server on background, and then starts the browser. And here it does a simple computation. You can click on a button, do +9, and compute the result.
So show the browser source.
Browser source, that should be similar to the previous one.
Yeah, I'm just curious.
Actually, this is style sheet. So this is the page. It basically says uses table to lay out the buttons, and each button has some ID.
Right.
And here again, it launches the virtual machine.
I'm curious about that Bck2Brwsr JS file and the VM JS file. Can you show us what it looks like?
Yes, I can.
Is it scary?
It's not scary for those who can read the bytecode.
Yeah.
But it's also huge. Basically, the smallest version I could come up compressed is 100 kilobytes. So but at the end, the whole Java virtual machine in 100 kilobytes is not that bad. Just this browser has problem to show the file for a reason, for unknown reason. Reload. Nothing.
Maybe you can, because I'm just curious about the implementation. How does this work under the hood?
Okay, I'll find a different way to show how the content of the file looks like. So basically, this is the source of the project.
Okay, great.
So let's open one project which is called Java Virtual Machine.
And of course, this is open source, and people can look at this and check it out and contribute.
That would be perfect.
So
and actually,
what kind of
some people do contribute.
What kind of contributions have you had, and what kind are you looking for?
I got a tremendous amount of help from Oracle guys working on FX. Basically, we can go to the project page.
Sure.
So it's a page on my website, apidesign.org, and it contains some instruction how to get started if you want. So this is basically all you need to do if you want to play with the stuff. And here is a list of to-dos, and here is also a list of done things.
Okay.
Martin Schoch and Lubomir Nerat helped me a lot with the correctness of the virtual machine. Martin works on proper arithmetics for integers, for longs, stuff like that, and Lubomir created a faster way of generating the code, so it runs much faster in Chrome browser. After his improvement, we got 10 times speed up of the executed code. So a list of things I'm looking for, well, basically anything here, and especially compatibility. People testing it and trying whether things are correct or not would be fantastic. And one thing that I also got is from Tony Apple.
Yes.
And it's API for drawing on a canvas. And Tony has a nice blog about describing how hard it was to write a library for Bck2Brwsr. And in fact, it was quite easy. So what I'd like to encourage is basically create an ecosystem of people who would be creating more and more Java libraries for various technologies which are available inside of a browser. And as Tony says, it's relatively easy. We can look at how complex that is, in fact. So first of all, how the generated code looks like. Okay, so we have a huge amount of tests, which basically says, okay, execute this method inside of this class, expect the result will be 7. So let's change it, and let's run the test. It should fail, I guess. And as soon as it fails, it basically prints out the generated JavaScript code. So we should be able to get to it. Here is it. So I'll try to open that as a JavaScript file. Open file. So now please don't be that scared. Prepare for the worst.
Okay.
So this is it. Actually, a really nice thing. Really nice thing. Editors, code faults, collapse all. So we have virtual machine function. If I expand it, you can see a list of classes which are available inside of the virtual machine. So these are the classes. And if you are interested in particular class, for example, this is the testing class. Oh no, let's see, static use. It basically says, let's expand it. No. Where are the methods? There's no methods. It should have some methods. So here is it. Okay, so let's expand the static class and let's expand methods. So here you can see the methods inside of the class. So in fact, it's a similar structure to what you would expect from a virtual machine.
So my question is, how do you convert Java to JavaScript?
By a class which is called, well, the main API is Bck2Brwsr class, but the main logic is inside of Bck2JavaScript class.
Okay.
And it basically generates the code. It generates the skeleton, and the raw meat is for understanding bytecode, which is done somewhere here. So we go, and for each instruction, we generate something similar in JavaScript, which is supposed to do the same.
And this
thing.
is what you created from scratch? This is not based on anything else?
No, that's my code. And now Lubomir's code as well, because he optimized it to be fast.
But it's so how is this different to what Google Web Toolkit does? Because you're also working with Java, and it's also converted to JavaScript. So
I'm converting bytecode.
Okay.
Google Web Toolkit is converting
and the source
Java code.
Yeah.
And it does it during compile time, which means certain features of Java just won't work. And then it's basically just I used to say that Google with Google Web Toolkit is piggybacking on Java. It's just taking Java as a language, but not as a framework.
Right.
Just it reuses the Java syntax, but it does not give you the features you would expect from Java runtime.
So this is happening at runtime. This conversion happens at runtime from the bytecode.
Yes, for your application classes, this is happening in the browser as soon as the class is loaded.
That's amazing. So what's the advantage of that, of having this at runtime instead of compile time?
It really feels like Java. The primary deployment method is still jar file with a bytecode inside of it. So you don't need to change your packaging. If you are used to package your application using AND as jar files, You have it. You have your application, and it can run inside a virtual machine. You don't need to change your build scripts. You don't need to change almost anything. Just the set of APIs that are supported inside of the
and you don't need a special GWT compiler or something.
Nothing
it's
like
just,
that.
Yeah.
Java.
It's
Java.
just native Java.
The only restriction is what we require is to use compile with target for JDK 1.6. You cannot compile for with target 1.5. We would not understand the bytecode. We need at least 1.6 target bytecode.
And okay, so we're getting to the end of our discussion. What is the future of this project? I mean, it seems to me that the possibilities are endless, and the
exactly.
and the competing technologies are very many, from Google Web Toolkit to applets. So where are you going with this?
I don't know. So competing technologies, applets. That's too heavyweight. This is really lightweight thing. Instead of deploying Java virtual machine and making sure it's installed on every computer on a planet, and on every mobile phone, every iPhone, which basically is not going to be true anytime soon. This guarantees that this will run in 100% of modern browsers. So it's really returning back the promise of Java to run everywhere. So that's the difference compared to applets. And as far as Google Web Toolkit goes, Google Web Toolkit is a bloated framework, which comes as a solution abstracted from Gmail. It's basically, first of all, that's my understanding. First of all, Google created something to write Gmail in, and then it created it into a toolkit, which is perfect for application like Gmail. But this is really starting from the bottom. We have virtual machine. And the library that I showed you for manipulating page is just an add-on. You don't need to use it. And actually, I don't want to get into business of writing libraries for accessing web pages, except just to demonstrate how powerful annotations can be. I want to encourage people to create their libraries and write them, which actually brings me to the point of showing how to create a library.
Okay.
But before we go there, one thing that we created as well is a development environment for web. And actually, it's basically using the power of Bck2Brwsr to provide you interactive environments. So here you have HTML5 page, here you have Java code, and here you have the result. And you can really modify it. So I can do set1 here, and after 2 seconds, the page is going to reload and it's going to be updated. And so now if I go here and change the, it's jumped, right? Change the result to 3, it computes power of 2 result. So if I call set1, it will change to 0 because I still have set0, but I can change the code to say set1 here. And as soon as it reloads, okay, I can press set1 and it will change. So you can play with it. This is an easy way how to allow people to get a feel for what it is to write using the Bck2Brwsr APIs and having application logic of HTML page written in Java-like style.
Excellent. Do you have other things to show?
That's how to write a library.
Mm-hmm.
So let me show you what Tony did. And actually, emulation Java Query API. So this is basically the additional library on top of the Bck2Brwsr, which defines also the Canvas APIs. So here is the API.
So this is what Tony created.
This is the part that Tony created. So he created a class called Canvas, And sometimes he needs to talk directly to the browser, so he needs a native method like this. But of course, we don't want to execute a native code, but we want to execute a JavaScript code. And for that, we have annotation, which basically says, okay, instead of body of this method, execute this JavaScript. And from the JavaScript, you can basically call back into the elements. So element is canvas, and you can access its fields if you want. So this is basically a way how you bind any JavaScript technology and create a lightweight wrapper around it that provides Java APIs. So this is basically the graphic context, which contains methods for drawing on the canvas, again written by Tony. And well, basically that's easy. It's one-to-one mapping with actual JavaScript canvas APIs.
Excellent. This is very exciting. Any final words before we finish up?
Well,
show us the page again, the API design.
Okay.
Yep.
So final words. You have just seen how the future of Java in a browser or future of Java is going to look like. So now it's your turn to make it even brighter. Please join the project, join mailing list, download the source code, experiment with it, and try to contribute.
Thanks very much.
Thank you.
Thank
Bye.
you.